Hey, Scott here, and we're going to try and do some crash courses on HVAC. Very quick crash courses. If you watch the video that I said where to begin, I just talked about the problem of having so much material, a year's worth of study, 5 hours a day, 5 days a week, trying to condense that into something that is usable and step by step for someone who wants to learn HVAC. If some of my videos on here, you're going to see basic air conditioning faults run through a simulating program. You really need to already have the basic principles down of superheat, subcooling, and a basic understanding of air conditioning and electrical to really get the most out of those. But just from the start, we want to talk about what can I do to help you understand the basics of air conditioning as quickly as possible. And if you watched that last video, I recommended that you check out somebody else's YouTube first on the refrigeration cycle. His name is Mike Ehrman. Just type in his name in the search, or How Air Conditioning Works Animation Part 1 of 3. Or you can watch all three of them. The first one's really critical. The first one really goes into the refrigeration cycle with a nice little animation. It's very easy to understand. Once you watch it a few times and really get it down, the refrigeration cycle shouldn't be too big of an issue. I'll also go over my version of it real quickly. I did this in the last video pretty fast. If you've watched Mike's and you're watching mine, we should get the refrigeration cycle down pretty quick. In any refrigeration system, you have basic components. This is going to be pretty true whether you're talking about a refrigerator, package unit, a residential unit. You have a compressor. In your outdoor unit, which is called your condensing unit, you have a compressor in there. You also have a coil around it and a fan motor. That is what your outdoor condenser is. The compressor is taking refrigerant gas, it's compressing it, and it discharges it out as a very hot discharge gas, like 200 degrees Fahrenheit. It's going to send that hot gas through a pipe until it gets to your condenser coil, and it's going to run that gas through this coil and encourage it to change state by getting rid of the heat energy that is stored in it. It's got a fan here. It's blowing this fan over those coils, probably at 90, 95 degrees, whatever the outdoor air temperature is. Because this hot gas is much warmer than the air going through it, 125 degrees is a lot warmer than the outdoor air. A lot of the BTUs, the heat energy, is going to transfer into that air and go outdoors. As it does that, it's going to start to change state because there's a certain pressure, and this system's designed to here it is, outdoor air is 95. It's going to maximize the efficiency to condense at just the right temperature. And in this one, the magic temperature is going to be 125 degrees. It's condensing in the evaporator, and when it goes through change of state, it gives off a tremendous amount of BTUs. That is the time when you're going from vapor to liquid that you're going to give off or give up a lot of heat energy. And as that heat energy is transferred out to the outdoors, that refrigerant is going to change its state into a liquid. This is the magic of air conditioning. As it takes that liquid refrigerant, it's going to take that liquid refrigerant out of the condenser, and when it gets outside of the condenser, it's now called the liquid line because it should be all liquid. It's going to send that liquid refrigerant into the house. It's going to stop at a metering device. That metering device and the compressor is going to separate the system into two systems, a high side and a low side. The high side is your condensing unit. That's going to be your high pressure side. And this metering device is going to restrict the flow of refrigerant. It's going to let it out through like a little hole, and it's going to shoot it out on the other side. It's going to instantly flash off about 25% to vapor. The rest will stay liquid. And now it's heading into the evaporator inside your house. It is much cooler now. You see that thermometer is at 40 degrees now. It is cooler and is going into your evaporator as a liquid and part gas. And as it goes through your coil, the evaporator coil, it's going to start changing state again, back into a gas. You got your indoor fan motor, and it's blowing, that fan's blowing over it, and it's going to be blowing the indoor air, which is roughly 75 degrees with 50% relative humidity. It's blowing that indoor air over the coil, and that indoor air is transferring the BTUs in that indoor air into this coil. So a lot of BTUs now are being absorbed by your evaporator. You could call the evaporator a heat sponge because it is just sponging up all the BTUs out of the air, and your air is coming out at 55 degrees out of your supply vent. By the time you get done with that evaporator, you should be 100% gas. 100% gas going through, and you're heading back to the compressor. You're picking up some heat energy as you travel through your pipe, and by the time you get back to the compressor, you may be 50 or 60 degrees of cool vapor, and that is going to cool down the compressor pump. That is your essential refrigeration cycle. That's the basics. Study this every day, and your first test is, stop the YouTube, watch Mike's videos, watch this video. After you get done with that, take a sheet of paper and a pencil and draw it out from memory, and see how well you can explain it to somebody else or explain it to yourself. Keep doing that, keep practicing it until you've got it, until you can explain and draw out this whole thing and you understand what's happening with the refrigeration cycle. After you can do that, we can go on to our next topic. So, for right now, focus on the refrigeration cycle, being able to draw it out, being able to explain it, watch Mike's videos, and we'll go from there.